Hello, the central limit theorem, part 2. Here we have a question. About 14% of employed adults in the US held multiple jobs. A random sample of 67 employed adults is chosen. Use TI-84 plus calculator as needed. Is it appropriate to use the normal approximation to find the probability that less than 8.1% of the individuals in the sample hold multiple jobs? If so, find the probability. If not, explain why not. So in this case, we're dealing with applying the central limit theorem for proportions, because we have 14%. That's a proportion, 14 out of 100. So we need to look at the central limit theorem for proportions, and here is the central limit theorem for proportions. Let p hat be the sample proportion. So we have a sample proportion for a sample size of n, and population proportion we will use lowercase p. So the population proportion is 0.14. You convert 14% into decimals. If the product n times p greater or equal to 10 and the product of n times 1 minus p quantity greater or equal to 10, then the distribution of p hat is approximately normal, which means that you have to satisfy both inequalities. And if one of them or both of them incorrect, so the NP will be less than 10 or this product is less than, you cannot treat their distribution of p hat as normal. And that means you cannot apply the central limit theorem and use normal CDF command and so on. So, but if it is true, then the distribution of p hat is the sample proportion, will be approximately normal, and we can apply the central limit theorem, but keep in mind that mu p hat will be the population proportion p, and sigma p hat will be this expression, square root of the quantity numerator p times 1 minus p, denominator n, the sample size. So let's see what we have here. We keep in mind this, and now we have to answer, is it appropriate to use the normal approximation to find the probability that less than 8.1% of the individuals in the sample hold multiple jobs? So first we need to look at the sample size. The sample size is 67 employed adults. The population proportion 14%. Let's put this all in writing as I usually do. So the population proportion 14% or 0.14. The sample size is 67. Remember from the previous video, we have to check the product of n times p. So n times p in this case will be 67 times 0.14. Let's see what it is. So we use our TI-84 and we calculate this product. We got 9.38. So it's 9.38. We compare 9.38 to 10. This is false statement. So we have not satisfied the first condition for the distribution of p hat be normal. Therefore, we cannot apply the central limit theorem. Therefore, we cannot treat distribution distribution. So our answer is appropriate to use the normal approximation. No, it is not. It is not appropriate to use. Since NP is 9.38 less, this sign, less than 10. So, okay, we answered question 1 out of 5. A new sample of 186 employed adults is chosen. Find the probability that less than 8.1% and so on. Let's first check if we can apply the central limit theorem with increased size of a sample. So again, this was in past, we cancel, so we check 186 times 0.14 and we use our calculator. We get 186 multiply 0.14 and we got 26.04. 26.04. Is this greater than 10? Yes, it's greater than 10. Now we need to check n times 1 minus p. Remember there we have to meet both conditions. Let me remind you where the second condition came. N times 1 minus p must be greater or equal. So what is n? N is 186 and 1 minus 0.14. You can see that it will be greater than this quantity, but be formal, we calculate this. So first follow the order operations. I will find what is 1 minus 0.14 times 186. So this will be almost 160, 159.96. 159.96. That is greater or equal to 10. So we're good, and we can apply the central limit theorem. Again, here's the central limit theorem for proportions. So now, once we see it, we can say that the distribution of p hat is normal and mu p hat, again, where this information came from the central limit theorem. So let's look at the central. So mu p hat is the population proportion and sigma p hat is this expression. Let's calculate. So mu p hat is 0.14 and sigma p hat, we calculate its square root of 0.14. Earlier we calculated 1 minus 0.14, 0.86, divided by 186, which is the sample size. Let's go ahead and use the calculator. So sample size 186. So let's use the calculator and see what it is. I will not use fractions here. I know I have on this calculator, but some people don't. So I will do with the order operations rule and show you that you can do this operation on any calculator basically. So and faster result. So now we just calculated the expression under the square root. Now we're going to apply the square root and apply the square root to this quantity. So we entered and our sigma p hat, which you don't need to calculate separately, but it's always good to know what it is 0.02544. 0.2544, because when you calculate using comments, and I put here 3 dots, means it continuous and has more digits. So now the question part 2 asks us, so for this, find the probability that less than 8.1% of the individuals in this sample hold multiple jobs. So less, so where are the less? So 8.1%, 8.1% in decimal notation, we move decimal point 2 places. That will be 0.081. So to visualize this, it will be somewhere here, 0.081, and we want to know what is the area under the normal curve, or in other words, probability that less than 0.081 of the individuals has multiple jobs. So let's go ahead and use our calculator again. To find the area under the normal curve, we use command normal CDF. It is number 2, and you come here and you enter lower. Lower is negative infinity, or -1 second, comma, for this symbol, which represents 10 to the degree 99. And here we have 0.081. It's important not to lose this 0, because that will be a different story. So 0.14, and here you can enter the expression with the square root, or you can enter what you calculated here. So 0.02544 is longer you copy this sigma, the better result with approximation. So we found the probability to be 0.0102, because here is 9. So the answer to this question is 0.0102. And that's our answer to question 2, where we looking for, let me restore this PDF file. So the probability that less than 8.1% of the individuals in this sample hold multiple jobs is very low, 0.0102. Find the probability that more than 7.6% of the individuals in the sample of 186, so the sample size remains the same, hold multiple jobs. Round the answer to at least 4 decimal places. Now let's look at the picture for this problem. Now more than 7.6%. Let's have, and we have a normal curve with mu p hat equals to 0.14 and sigma 250.02544. Now, what does it mean more than 7.6%? 7.6% in decimal notation is 0.076. So where this number? It is here somewhere, 0.076, because in the middle we have 0.14. So now more will be area to the right over here under the normal curve. So when you use your TIHF form, you use again because normal CDF, because you need to find the area under the normal curve. So you go ahead and put. So let's go ahead and calculate, and we got 0.9941. The answer is 0.9941, because they want us to answer round to 4 decimal places. So the answer is 0.9941. So that was the question number 3. Find the probability that proportion of individuals in the sample of 186 is between 0.16 and 0.99. Easy, and we just change in normal CDF two parameters, 0.16 and 0.19. And everything else remains the same. We have answer of 0.1912. 0.1912. Question 5. Would it be unusual if less than 12% of the individuals in the sample held multiple jobs? Less than. So again, the unusual event is event whose probability less than 0.05. So here less than 12%. 12% is 0.12. So let's use our calculator and find if it's unusual that less than 12%. So we're going to have less than 12%, -1 second E99, and here 0.12, and everything else the same. So the probability is 0.2159. So the probability that less than 12% is pretty high, 0.2159. It's much greater than 0.05, so we say it is not unusual since it's not less. So we say it would not be unusual if less than 12% of the individuals in a sample of 186 held multiple jobs, since the probability is 0.21 so on, greater than 0.05. Well, we answered this question. So now look at this question. Each of the following normal quantile plots illustrate a sample. In which cases is it reasonable to treat this as a sample from approximately normal population? Approximately normal population. So here we need to recall that we will reject the assumption that the population is approximately normal if a sample has any of the following features. The sample contains an outlier. The sample exhibits a large degree of skewness. The sample is multimodal. In other words, it has more than one distinct mode. If the sample has none of the preceding features, we will treat the population as being approximately normal. So in the language of dot plots, it means that the dots kind of equally distant from each other and align along straight line. That's what it is. So we need to choose this, and we need to look at the other two, and between these two we choose this option. So there are two quantile plots that we can classify as suitable to treat a sample as a sample from an approximately normal population.